Welcome to This Explainer. Today, we're diving straight into one of the absolute coolest, most mind-bending space exploration achievements of our time. We're talking about Chandrayaan 3. And look, this wasn't just a mission that pushed the boundaries of what's possible. It essentially rewrote the book on the moon's most mysterious, rugged region. To really grasp how huge this is, we got to start right at the climax. August 23rd, 2023. The Indian Space Research Organization, ISRO, puts out this simple but unbelievably heavy statement. Just picture the pure, raw tension in that control room. You're trying to gently land a robotic spacecraft hundreds of thousands of kilometers away. You've got a 1.3-second communication delay, so you can't just grab a joystick and pilot the thing. The onboard computers literally have to figure it all out on their own, in real time, while plummeting toward the surface. When that touchdown confirmation finally came through, man, it wasn't just a win for India. It was a massive win for human ingenuity. Now, we do need to be super precise about exactly where history was made here. The Vikram lander touched down at 69.37 degrees south and 32.32 degrees east. So a lot of the headlines were just screaming, South Pole. But if we want to be scientifically accurate, it was actually about 600 kilometers away from the exact geographic South Pole. But hey, make no mistake, touching down in this high-latitude southern region, it was a totally unprecedented first for humanity. NASA's Lunar Reconnaissance Orbiter even confirmed it independently. Nobody had ever pulled off a soft landing this far south before. And, this didn't just happen overnight. It's part of this incredible redemption story. Back in 2008, you had Chandrayaan-1 mapping the moon from orbit. Then, 2019, Chandrayaan-2 successfully placed an orbiter, but the lander, unfortunately, didn't make the soft landing. But here's the thing about aerospace engineering. Failure is just data. The engineers completely tore into the 2019 data, figured out what went wrong, redesigned the systems, ran relentless tests, and that grunt directly paved the way for the total triumph of Chandrayaan-3.
Section 1. Mastering the Final Descent. Engineering the Impossible.
So how exactly did they pull off this cyber-physical miracle? Well, let's break down the hardware. It was basically a three-part setup working in total harmony. First, you've got the propulsion module, which is essentially the space taxi that hauled everything out to lunar orbit. Then you've got the Vikram lander. That's the star of the show, the unit actually responsible for the incredibly complex descent. And finally, folded up inside Vikram was the Pragyan rover, this tiny, brilliant robotic geologist built to roll out and zap the lunar dirt. Getting down to the surface, though, it required a terrifyingly fast, automated sequence. It starts with high-speed orbital motion. Then, bam, controlled braking violently kicks in. After that, you've got hovering and trajectory correction, where the lander literally has to scan the ground below it with its cameras to find a safe spot that isn't covered in boulders. Next is the vertical descent, and then touchdown. Keep in mind, the moon has 0 atmosphere. You can't just pop a parachute. The spacecraft autonomously fired its rocket engines against its own momentum, doing this insane balancing act of altitude, velocity, and orientation. And here's the kicker. They had to execute all of that math across a staggering distance, 384,000 kilometers from Earth. Because of that massive gap, manual control is literally out of the question. Every single sensor, camera, computer, and thruster had to talk to each other in fractions of a millisecond to nail this landing safely. Section 2. Discoveries in the dust, the robotic geologists. Once the dust literally settled, the real work started. The nail-biting tension of the landing turned into this super exciting scientific treasure hunt. The whole point here was to get what scientists call ground truth. For decades, we've been staring at the moon from orbit, making really good, educated guesses about what it's made of. But with Vikram safely on the ground and the Pragyan rover rolling around, scientists could directly analyze the regolith, the lunar soil, right there on the spot. Pragyan was carrying these tools, APXS and LIBES, which literally shoot high-powered lasers and X-rays at rocks to see what elements spark back. We're talking direct, undeniable, hard data. So what actually happened when they laser zapped those rocks? Well, the instruments kicked back a spectacularly long list. We're talking aluminum, calcium, iron, chromium, titanium, manganese, silicon, and oxygen. But the absolute crown jewel of the entire list? Sulfur. Finding sulfur through in situ direct measurements, right there on the ground in this specific region, that is a massive deal. It gives scientists huge clues about the moon's volatile elements and how it originally formed. And it actually gets deeper than that. A groundbreaking study that came out in Nature Communications Earth and Environment showed some really unusual patterns in that lunar soil. Researchers actually think Pragyan found evidence of primitive lunar mantle material. The running theory is that billions of years ago, a massive asteroid slammed into the moon, creating the nearby South Pole Aten Basin. The sheer, violent force of that impact churned up material from the deep, ancient interior of the moon and basically tossed it right over to where Chandrayaan-3 eventually landed. Oh, and speaking of craters, scientists made another wildly surprising discovery, which was reported in the journal Icarus. The landing site they picked wasn't just some random flat plain. It turns out Vikram landed inside a heavily degraded, totally buried impact crater that's roughly 160 kilometers wide and 4.4 kilometers deep. That completely turns the landing area into an active geological laboratory. It means every single slope, layer, and rock nearby is holding on to ancient secrets about the early days of our solar system. Okay, we actually need to pause here for a quick but super important reality check. You might have seen some stuff online claiming that Chandrayaan-3 went down to the South Pole and mined massive amounts of water ice. That is absolutely false. It's true that the South Pole region is famous because it has these deep, permanently shadowed craters that trap ancient ice. But Vikram actually landed in the sunlit region. It had to. It completely relies on solar power. The goal was to run broader geological studies of the surface, not to set up a mining rig inside a pitch-black crater. Scientific accuracy really matters when we're unpacking these historic missions. Now, right before the 2-week lunar day ended, Vikram pulled off one last, almost secret bonus trick. On September 2nd, the lander actually reignited its main engines and did a 50-centimeter hop. It lifted off the dirt, moved over slightly, and touched back down using its leftover fuel. Why on earth does a tiny, half-meter hop matter? Because it proved they can successfully restart the engines and lift off from the lunar surface. That is the exact capability we are going to desperately need for future missions that aim to scoop up lunar rocks and fly them all the way back home to Earth. Section 3. A cosmic stepping stone, the bigger picture. To truly zoom out and appreciate why scientists obsess over these specific lunar rocks, you just have to look at our own planet. Earth is incredibly active, right? Between erosion, plate tectonics, weather, and life itself, the surface is constantly being destroyed and recycled. The moon, on the other hand, is dead. It doesn't have those destructive processes. It acts like a pristine, untouched fossil record. When the Pragyan rover analyzes a rock, it is literally looking at a snapshot from billions of years ago. By studying the moon, we are actually learning about the early chaotic days of Earth and how our entire solar neighborhood came to tether. So, when all is said and done, how do we grade the success of Chandrayaan-3? I think it operates brilliantly on 3 different levels. Level 1, it's a massive national achievement, definitively proving India's incredibly advanced spaceflight capabilities. Level 2, it's a huge scientific win, giving us direct, ground truth measurements of a totally unexplored environment. And Level 3, which is maybe the most important, it's a human achievement. As a species, we expanded our reach into a really challenging, dangerous new world. And it's definitely worth noting, this was a global team effort, with critical tracking and communication support coming from both NASA and the European Space Agency. And the data we got from Chandrayaan-3, it's really just setting the stage. Future missions heading back to this region are going to investigate water ice for actual resources. They're going to test how human bodies handle lunar radiation, build out surface power grids, and perfect the autonomous robotics we need to bring samples home. The lunar South Pole isn't just a cool destination anymore. It is the ultimate strategic testing ground for the entire future of deep space exploration. Which leaves us staring up at the stars with one final thrilling question. As we learn to survive and master the moon's absolute harshest environments, are we actually looking at the very blueprint for humanity's eventual journey to Mars? Every rock zapped, every little hop made, and every bite of data Chandrayaan-3 beamed back brings us one step closer to finding out. The mission itself might have only lasted a single lunar day, but the science is still pouring in, and the legacy of this landing is going to echo for generations. Thanks for hanging out with me for this explainer. Keep looking up, and I'll catch you next time.